recording. Then we continue with our lecture. But before that, I think I want to go to our course. Can you see my Yulen here?
Can see, Doctor.
Okay, in the assessment part, I already put the how our evaluation will be, what are we going to evaluate you. Okay, so here we have test 20%. The test contain of analysis of categorical data, non-parametric statistic, and multivariate data analysis. Actually, these two part is from Dr. Sack, right? And multivariate data analysis is from me. Okay, it's on the test. But for the assignment as individually, and topic cover from my class, Dr. Sack class, and Dr. Fauzia. Actually, for the assignment, you're given a duration to finish it. Then you may refer to all the sources. Then you may submit your assignment by later on we'll put in the ULearn when to submit the assignment. Actually, the assignment will be given to you after Dr. Fauzia class finish lah macam tu. Okay, clear tak? Ni Dr. Set tak terangkan lagi kan?
Belum, Doctor.
Okay, so after that, we have also project 30%. Project in a group consists of topic time series project. Okay, actually the data beside the notes is dia tak berkaitan Okay, and okay, this is the carry mark which is 20, 20, 40, 70. And this is the numeracy is also carry mark. It is exercise in class. Actually, the numeracy ni later on Dr. Fazia will cover on it. It is like an exercise in a class. Then you will given some duration, but in a short, if you want to compare with the assignment, but you may refer to other sources, then you will submit it and you get 10%. And our final test later on is on my topic ANOVA. After this, we will learn ANOVA. But tonight, we only cover on multivariate. And after that, regression, PCA, and EFA is from Dr. Fauzia. And time series and SPC is from Dr. Siti Azira for the final test. Okay, so this is our mark, which is the kerja khusus is actually 70, but numeracy is combined with the final test later on. Okay, maksudnya dia 70-30. Before you sit for the final test, you already know your position, which is whether you the mark you get. Okay, is there any question?
No, doctor.
Okay, so we proceed with our lecture today. Okay, if you have a question, you may interrupt and you may ask. Okay, sebab saya tak nampak tau orang-orang yang kat situ, and I can't see your chat because I'm sharing my screen. But if you have question, you may raise your hand and ask. Okay, this is the introduction to multivariate data analysis. Actually, this book, we are using this book. It's open. You can get it from the internet. Multivariate data analysis, this book. The cover is like this. Okay, then this is the learning objective for today. First, explain what multivariate analysis is and when its application is appropriate, and define and discuss the specific technique included in multivariate analysis. Determine which multivariate technique is appropriate for specific research problem, and discuss the nature of measurement scale and their relationship to multivariate technique. And finally, describe the conceptual and statistical issue inherent in multivariate analysis. Actually, for my part, it's like a general knowledge. Okay, for this introduction to multivariate data analysis. Okay, what is it actually, multivariate analysis? Multivariate data analysis is all statistical method that simultaneously analyze multiple measurement on each individual or object under investigation. Actually, this multivariate, the name of multivariate. Saya boleh, only I can, okay, only I can annotate. Okay, this multivariate, it means that it has many variate. Macam kita ada, if we call it, if we say multi-purpose, okay, that's many purpose, right? Multivariate, which contain many variables. Okay, and it's measured on individual or object under investigation. For example, if we have one individual had graduated from UTEM, and what's the variant that we want to cater on that particular person? For example, that alumni, we want to know whether it's successful, maksudnya dia maksudnya macam graduate employability, but we want to know whether this kind of person berjaya tak dapat pekerjaan under course yang diambil. Maksudnya, so ada beberapa variant yang kita ambil kira. Contohnya kita ambil kira di mana dia LI, is he graduate on time or not, and what subject that he take, and apa lagi, the CGPA, that's all the factor. That's the multivariate on one individual, which is the student, the alumni student. Okay, why use it? Okay, kenapa kita guna? To measurement, to make as a measurement, and explanation and prediction, and so lastly is for hypothesis testing. Okay. Sekejap ya. Dia dah tak bergerak macam mana. Saya tak biasa guna ni. Sekejap ya. Okay. Okay, basic concept of multivariate analysis. Okay, pertama is we have the variate and the measurement scale, non-metric ke metric. The variate is how many factor just now, right? The measurement scale is skala dia. Contohnya dia kita guna dia non-metric or metric. For example, from that graduan tadi tu, is he lelaki ke perempuan? Lepas tu dekat mana dia bekerja, adakah data tu dari segi nombor ke apa ke, maksudnya company mana, and other than that is whether it is graduate on time or not. Contohnya kat situ dia skala, maksudnya we use many measurement scale there. Okay, and the concept also multivariate measurement, and we have also measurement error and types of techniques. Okay, so first we go to the variate. What is the variate? The variate is a linear combination of variable which empirically determine weight. Okay, weight here determine the best achieve the objective of the specific multivariate technique. Actually, this kind of equation you already many times see it. Maksudnya ini is persamaan linear, right? Is variate equation. We have this factor number 1, factor number 2, until factor number n. But beside it, we have weight. So weight determine the best achieve the objective of the specific multivariate technique. Okay. So each respondent has variate value y prime. Okay. This is our the one that we want to measure, right? So the y prime value is a linear combination of entire set of variable, meaning that we have entire many variable here, x1, x2, x3 until xn, and the combination is linear, which apa yang dimaksudkan dengan linear, which is it's not polynomial because it's power of 1, dia darjah 1, berdarjah 1, which is power of 1. It is the dependent variable. Okey, ni y prime ni is dependent variable. Kalau kita boleh imbas kembali matematik kan, if we have this kind of coordinate, we have value of x and we have value of y, which one is dependent variable? Do you know? For example, x representing the apa ya? Hari lah. Contohnya x ni ialah hari. Hari. Okey, Y ni pula ialah sales dia, jualan dia kan, macam tu kan. Okey, hari yang pertama jualan dia dekat sini. Hari yang kedua jualan dia dekat sini. Hari yang ketiga jualan dia dekat sini. Hari yang keempat jualan dia dekat sini. Contohlah. Okey, tapi yang ni dia linear kan. Okey, contohnya jualan yang kelima, hari yang kelima jualan dia dekat sini. Okey, cuma saya nak kita imbas kembali. What is dependent variable? Another one variable apa? Independent, right? Okay, independent ni is yang tidak bergantung dengan apa-apa value. Which is the independent variable is the value of x. Kalau kita punya case ni, independent variable dia ialah x1, x2 until xn. This is independent. Dia tak bergantung dengan apa-apa value. But the dependent variable, it obviously the y. Because yang Y punya value bergantung kepada jualan pada hari pertama. Ini contohnya dekat sebelah ni. Maksudnya ini jualan je. Maksudnya dia punya X only one, which is the sales. Maksudnya hari yang pertama, hari yang kedua, macam tu kan, hari yang ketiga kat sini. Okey, tetapi yang dekat sini the variate dia macam pelbagai. Tapi dia x1 until xn is the independent value. Dia tidak bergantung dengan apa-apa. But for the y prime value, it is bergantung kepada kalau berubah nilai x1 maka berubahlah nilai y prime ni. Maksudnya it depend on the x value which is the dependent variable. Okay, itu saya recap balik apa yang dulu-dulu punya belajar lah kat situ. Okay, and potential independent variable, it's like an income, education, family size and many more lah kat situ. It's like a factor. Kan kat situ yang memberi impak kepada y value. Apa y value yang kita nak cari kat situ. Contohnya faktor maksudnya kepada macam kesihatan kepada kesihatan individu ke, adakah income, education, family size apa semua memberi impak kepada individu tu sendiri ke tidak. Inilah faktor-faktornya. Okey, contoh yang tu. Okey, so seterusnya, okay, this is the data type and measurement scale. We have data, then in this data we have non-metric or qualitative data and metric or quantitative data. Kalau qualitative or non-metric is nominal scale or ordinal scale. For metric and quantitative, we have interval scale, ratio scale. And the definition of non-metric and metric is here. You may read by yourself. But, okay, nominal size of number is not related the amount of the characteristic by measured. Yang ni lah nominal scale. Contohnya kat sini, it used to label variable in different classification and does not imply a quantitative or value or order is nominal scale, whether it is A or B. Okay, then we have also ordinal scale in the non-metric punya data. Non-metric which is apa just now? Qualitative. Ordinal. Ordinal is larger number indicate more or less of the characteristic measure. Is like this ordinal scale. Represent non-mathematical ideas such as frequency, satisfaction, happiness, a degree of pain. Macam ni lah. Contohnya kalau yang ni is we satisfied or not with the services. Kalau macam kadang-kadang doktor kan dia tanya, yang ni kadang sakit ni dekat yang mana? Maksudnya sakit sangat ke? Atau masih boleh lagi? Macam tu lah dia macam nak, dia kelaskan macam tu. Okay, ada beberapa kelas kat situ. Okay, and we have also just now metric or quantitative, we have interval scale and ratio scale. What is interval scale and ratio scale? it is ordinal properties for interval. Interval is rate from 1 to 7 your experience, which is very unsatisfied and very satisfied. Sorry, kat sini kita jawab dekat dalam survey kan, selalunya linked scale macam tu kan. Is define a numerical scale where the order of variable as well as the difference between this variable is known. Okay, another one in the quantitative just now is what? Ratio scale. We want to give a scale whether this hamburger can you eat, how many hamburger can you eat a day? Whether from in a range of 1 until 2 ke, atau 2 until 3 ke, 4 until 5 ke, more than 5. Ini kita macam bagi skala. Selalunya kalau kita tengok dekat dalam survey, dia akan letak kita punya scale ni macam kita punya pendapatan kan selalunya antara 500 ke 2000. Pendapatan anda daripada 2000 ke 5000. Macam tu dia dah skalakan siap-siap kat situ. And you may read the further information of this kind of data from the link that I gave in the slide. Actually the slide I put in the ULearn in week 5 tau, dah ada tau. Okay. For the measurement error here. Just now kan kita ada, kita akan belajar measurement scale, whether kita dah masuk dekat non-metric and metric. So we are here, multivariate measurement and measurement error kat situ kan. Okay, so kat situ, we have measurement error kat sini. All variable have some error. What are the source of error? Okay, yang ni kita kena tahulah dekat mana source of error tu. And measurement error distort observed relationship and make multivariate technique less powerful. And researcher use some method scale for which several variables are sum or average together to form a composite representation of a concept. Okay. Kat situ je ya. This is measurement error. Okay, so the measurement error actually, siapa yang pernah ambil fizik dekat sekolah dulu, dia dah belajar dah for the validity and reliability. Okay, in addressing measurement error, researcher evaluate two important characteristics of measurement. Whether its validity or reliability. What is validity? The degree to which a measure accurately represents what it is supposed to. And reliability is degree to which the observed variable measure the true value and is thus error-free. Okay, kalau tak faham ni, kita tengok gambar. Okay. It's like, kalau dulu fizik kan, dia macam dia menumpu ke, persis ke, macam tu kan gambar dekat dalam buku teks fizik tu. Okay, so for this kind of situation, we said this is not reliable and also not valid because of it's not menumpu kepada satu yang kita punya objektif dekat tengah-tengah ni, and it also berselerak macam tu kan. And this kind of finding is reliable because dia macam persis, maksudnya dia rapat tetapi dia tak ada dekat pun dengan kita punya jawapan, tapi is reliable. Maksudnya finding yang sebelum-sebelum ni pun dia macam lebih kurang kat sini juga. So our method is reliable enough lah kat situ. And this kind of situation yang bawah ni pula is but it is reliable but it is not valid because dia tak dapat dekat objektif kita yang dekat tengah-tengah tu kan. Okay, but in this situation it is valid sebab dia ada dekat tengah-tengah tu, dia ada yang dapat dekat kita punya objektif, but it's not reliable because the jawapan dekat situ dia mencapah kan, dia tak menumpu kat satu tempat. And for this kind of situation it is reliable and is also valid, this situation. And for reliable and validity and reliability, you may see from the video explanation below ni kat sini ada kat sini. You may see after this, and I want to continue. Okay, in statistical significance and power. Okay, in here, we have type 1 error, which is alpha, is the probability which is here. Type 1 error alpha. Probability of rejecting the null hypothesis when it is true. Okay, H null is true, but it's reject. Okay, in reality, it's reject H null. Okay, but for the type 2 error, ialah beta ni, type 2 error kat sini, is the probability of failing to reject the null hypothesis when it is false. Okay, and here where the correct decision that we have, and also here we have the correct decision. It is power here, or 1 minus beta is the probability of rejecting the null hypothesis when it is false. Okay, untuk bagi lagi jelas, jom kita tengok video ni kejap. Saya suka tengok video ni.
New Vaseline Gluta-Hya Pro Age with 70 times collagen for firm and radiant skin.
Minus beta is called the power of.
Dengar tak?
Yes, boleh.
Boleh kita tengok daripada mula lah ya.
In this lesson, we will learn about the errors that can be made in hypothesis testing. In general, we can have two types of errors, type 1 error and type 2 error. Sounds a bit boring, but this will be a fun lecture, I promise. First, we will define the problems, and then we will see some interesting examples. Type 1 error is when you reject a true null hypothesis and is the more serious error. It is also called a false positive. The probability of making this error is alpha, the level of significance. Since you, the researcher, choose the alpha, the responsibility for making this error lies solely on you. Type 2 error is when you accept a false null hypothesis. The probability of making this error is denoted by beta. Beta depends mainly on sample size and population variance. So if your topic is difficult to test due to hard sampling or has high variability, it is more likely to make this type of error. As you can imagine, if the dataset is hard to test, it is not your fault, so type 2 error is considered a smaller problem. We should also mention that the probability of rejecting a false null hypothesis is equal to 1 minus beta. This is the researcher's goal, to reject a false null hypothesis. Therefore, 1 minus beta is called the power of the test. Generally, researchers increase the power of a test by increasing the sample size. This is a common table statisticians use to summarize the types of errors. Now, let's see an example that I heard from my professor back when I was studying statistics in university. You are in love with this girl from the other class, but are unsure if she likes you. There are two errors you can make. First, if she likes you back and you don't invite her out, you are making the type 1 error. The null hypothesis in this situation is, she likes you back. It turns out that she really did like you back. Unfortunately, you did not invite her out because after testing the situation, you wrongly thought the null hypothesis was false. In other words, you rejected a true null hypothesis and lost your chance. It is a very serious problem because you could have been made for each other, but you didn't even try. Now, imagine another situation. She doesn't like you back, but you go and invite her out. The null hypothesis is still, she likes you back, but this time it is false. In reality, she doesn't really like you back, that is. However, after testing, you accept the null hypothesis and wrongly go and invite her out. She tells you that she has a boyfriend that is much older, smarter, and better at statistics than you and turns her back. You made a type 2 error, accepted a false null hypothesis. However, it is no big deal, as you go back to your normal life without her and soon forget about this awkward situation. Hypothesis testing is usually like that. You don't really want to make any of the two errors, but it happens sometimes. You should be aware that statistics is very useful, but not perfect. Alright, that's all from our love/life/statistics lesson. Thanks for watching.
For more videos like this one, please subscribe.
Okay. Okay tak?
Okay, very interactive.
Saya rasa macam lagi faham sikit kan what is type 1, type 2 macam tu kan. What is the H0 and fail to reject H0 punya situation lagi mudah kan kat situ. Okay, here I give also to you case study here what is type 1, type 2 punya situation and also the power in a case of I think in national, okay, if we can look at this case study. It is type 1, type 2 error and statistical power from National Library of Medicine here. Here the definition and issue to be concerned and what is the power punya situation. You may you may go through it after this and I also provide you another related video. What is type 1, type 2 and also the power punya situation. Okay, so we continue Okay, and this is the power just now, which is here. The power 1 minus beta, which is correct definition decision here. Okay, the effect of this power is determined by 3 factors. Effect size, the actual magnitude of the effect interest, for example, the difference between means or the correlation between variable, and for the alpha, as alpha is set smaller level, power decrease. Okay. Typically, alpha is 0.05. Okay, and also the third one is sample size. As the sample size increase, power is also increased. With very large sample size, even very small effect can be statistically significant, raising the issue of practical significance versus statistical significance. Okay, so here we can see this is the sample size. If we have the alpha just now 0.05 like this, and this is the situation where our alpha is 0.01 and this is the effect size. If we get the effect 0.2, we can see that this is the value for 0.2, which is 0.95, and if our alpha is decreased 0.01, this is our result 0.025, and for the moderate one we can see it's increased compared to the small one here. But if we increase our sample size here, and we can see that the result obtained is more higher, but this one is more higher than the smallest alpha here. Okay, so this is where the just now the statement, which is the sample size. As the sample size increase, power increase, and as alpha is set smaller level, power decrease. Nampak tak kat situ? Okay, then this is the relation between power, sample size, and the effect size is 0.35. Okay, and if the sample size is increasing, then we can see that our power will be increased also, but it will depends on the alpha. If we put the higher alpha, then the result must be bigger than the smaller alpha. Here the relation between power and sample size. And this is, I'll put the link for the further explanation and exercise for this impact of sample size on power. Okay. And this is the rule of thumb. Statistical power analysis. Okay, researchers should always design the study to achieve power level 0.8 at the desired significant level. More stringent significant level, for example, 0.01 instead of 0.05 require larger sample to achieve the desired power level. Okay, meaning that if we put 0.01, we have to put a larger sample, right? Okay, then the conversely, power can be increased by choosing the less stringent alpha level. Okay, for example, 0.1 instead of 0.05. Okay, smaller effect size always require larger sample size. Okay, like this. Effect size, if it is smaller, we have to put the larger sample size to make the result increase to achieve our objective. Okay, and any increase in power is most likely achieved by increased sample size. Okay. Here I also put a link to you to read further. And this is, we continue with type of multivariate technique. We have a lot of multivariate technique yang kita biasa dengar. Okay, so first is dependent techniques. Okay, a variable or set of variable is identified as the dependent variable to be predicted or explained by other variable known as independent variable. Okay, for example, the type of multivariate for dependent techniques is multiple regression, multiple discriminant analysis, logistic regression, MANOVA, multivariate analysis of variance, and covariant. Later on in our next class, we'll cover on this multivariate analysis of variance and covariance and conjoint analysis. Kerana yang ni, the SEM we cover in Dr. Fauzia class later on. Also with multiple regression. Okay. Actually, in this applied statistical method, we not explain all the techniques, but if you already know one, maybe more than if you learn from this course like multiple regression or MANOVA later on, if you read for the multiple discriminant analysis, you may can I answer, you may understand it easily, because previously I also in numerical method we only learn a few of method in that particular subject, but in the real situation, if we do an experiment, if we have to look at other method, it's easier for us to understand because we already have the fundamental one. Okay, which is we already know the method yang lebih kurang. Cuma kita nak sesuaikan dengan kita punya keadaan je. Okay. Then next is interdependence technique. Here, interdependence technique, we learn about principal component and common factor analysis. Here, we will learn this kind of technique from Dr. Siti Azira, cluster analysis. Okay, yang ni multi-dimensional scaling ni kita tak cover. And correspondence analysis is the first contoh. Kita ada contoh untuk interdependence technique kat sini lah. Kita ada 1, 2, 3, 4 technique. Okay. And how can we select a multivariate technique? Okay, first we have to know what type of relationship is being examined. Okay, adakah relationship between y prime just now, y prime dengan yang x semua tu kan yang mula-mula kita belajar tadi, adakah dia punya relationship tu dependence ke atau interdependence? Okay, if it is dependent relationship, you may refer to the, you may investigate how many variables are being predicted. And after that, what is the measurement scale of the dependent variable? And yang selepas tu, what is the measurement scale of the predicted variable? And for the third one is interdependent relationship. Are you examining relationship between variable ke atau between respondent or object? Okay, this is our step to select multivariate technique. Lepas kita tahu dia dependent and interdependence, kita kena tengok pula seterusnya. Because of what? Because the skala yang dependent variable ni semua kita kena tahu, sebab kat situ kita ada seterusnya, kita ada yang ni nanti. Okay, so kat sini two broad type of multivariate method, which is dependent and interdependence. Which is dependence ialah analyze dependent and independent variable at the same time, and interdependent is analyze dependent and independent variable separately. Okay, yang table ni dia macam membantu lah, which is we have multivariate method whether our case tu dependent method ke atau interdependent. So after that we look at the variable used, whether one dependent variable and is it involve metric punya skala. So if it is involve metric punya skala, we will know that we have to consider multiple regression or conjoint. Or if this one dependent variable, it involve non-metric scala, then we have to consider discriminant analysis or logistic regression here. Or another one, if our dependence method on several dependent variable, and when we look at the scala, the data, it is metric, and we have to consider by using MANOVA and canonical. If it is non-metric, we have to use okay, canonical ni nampak tak? This is canonical and this is canonical correlation. Okay, and dummy and variable. There is some different between canonical and canonical correlation yang kita kena tengoklah what is canonical correlation and what is canonical to further our study. And here interdependence method pula, also we have to consider whether it is metric or non-metric. If it is metric, we have to use factor analysis and cluster analysis or metric MTDS. And if it's non-metric, the method that we have to consider is non-metric MTDS and correspondence analysis. But here, nampak tak kat sini? We also have the hybrid. Macam kita ada dua tau, dependence method dengan independence method ni dekat tengah-tengah, which is multiple relationship structural equation, SEM and CFA. Yang ni nanti SEM ni cover in the lecture Dr. Fauzia. Dekat mana kita nak tengok macam mana keadaannya when we call it as a multiple relationship structural equation dekat situ. Okay. And this is the definition lah. Kalau tadi kita nampak ada banyak method kat sini kan, on the interdependence and for the dependence, yang ni dia pergi satu persatu lah. Contoh dekat situ when it is multiple regression. Ini ialah single metric dependent variable is predicted by several metric independent variable. Okay. Yang ni kalau dulu, kalau dia student dah dekat sini banyak yang electrical kan, dekat electrical, tapi computer science pun ada juga belajar multiple regression. Multiple regression in numerical method. Bila nak multiple regression, kalau kita ada one equation of, kalau kita ada y sama juga dengan mx campur c, dekat situ, yang ni ialah linear regression tau. Tapi kalau multiple regression itu dia dah macam y, dia macam keadaan kita tadi, which is dalam ni ada x1 campur x2 campur x3 campur x4 dekat situ. Dan seterusnya. Itu kita kata dia dalam satu linear, maksudnya dia ada pelbagai x dekat sini. Okay, a single metric dependent variable is predicted by several metric independent variable. Maksudnya dia banyak independent dalam tu. Tapi kita nak predict satu benda ni. Contoh saya baru dapat ada hari tu, pelajar daripada mechanical dia datang dia bawa equation dia. Lepas tu equation dia saya tengok dia punya masalah tu, bila kita tengok masalah tu dia ialah satu yang berkenaan dengan tayar tau. If one lorry dia ada 6 tayar contohnya, kita nak tahu the angle of the tayar macam mana, dia punya torque value macam tu lebih kurang, tapi saya tak pandai nak fahamkan tu, tapi saya faham apa yang dia cuba nak selesaikan. Waktu tu yang kami come out with there's something yang macam multiple regression, which is yang ni dia punya stability, but here is the tayar tu punya torque, but it contain weight kat sebelah-sebelah tu. Dia kena guna this multiple regression. Okay. Kat situlah saya nampak sebab the previous punya kajian pun memang dia guna multiple regression, tapi dia punya variable tu semua ialah tayar yang pertama, tayar yang kedua, tayar yang ketiga punya ability. Dia boleh bergerak berapa, macam dia punya lencongan semua tu lah. It's memberi satu nilai kepada stability of that vehicle lah, macam tu lah, guna multiple regression. Okay. Itu satu case lah kat situ. And discriminant analysis. What is discriminant analysis? It is single, non-metric, which is categorical. Dependent variable is predicted by several metric independent variable. Okay, why we have to use discriminant analysis? For example, dependent variable dia ialah gender, whether it is male or female, and culture. Is it USA versus outside USA, purchaser versus non-purchaser, and member and non-member, good average and poor credit risk. Ini macam kita nak cari, kalau macam purchaser and non-purchaser ni mungkin ada something yang kita nak tengok. Apa yang faktor yang orang membeli dan bukan, kan? Okay. So, on the logistic regression, a single non-metric dependent variable is predicted by several metric independent variable. Okay, this technique is similar to discriminant analysis, but relies on calculation more like regression. Okay. Here, what is discriminant analysis? Just now, dah ada discriminant. Okay, logistic pun dah. MANOVA. Okay, this one method that I said that we learn about it later on in our third class. Okay, several metric dependent variable are predicted by a set of non-metric categorical independent variable. Okay, this is MANOVA. And canonical analysis is several metric dependent variable are predicted by several metric independent variable. Okay, this is what we call a conjoint analysis. It's used to understand correspondent preference for product and services. Okay, in doing this, it determines the importance of both, which is attribute and level of attribute, based on some smaller subsets or combination of attribute level. Later on, okay, this is, later on I'll give a case study, then you may read what method that they use in order to analyze their objective apa. Okay, and here is conjoint analysis, which is typical application like soft drink, candy bar, cereal, beer, apartment building, condo, solvent, cleaning fluid. Okay, ni macam kepada banyak typical application for conjoint analysis. And this is what we call SEM, structural equation modeling. Okay, to estimate multiple interrelated dependent relationship based on two components. First is measurement model and structural model. Okay, ini pun kita akan belajar nanti. And factor, exploratory factor analysis. Okay, analyze the structure of the interrelationship among large number of variables to determine a set of common underlying dimension factor. Okay, kalau macam exploratory factor analysis ni, kalau macam dalam project kita memang guna project 1, project 2, because if we have a data later on, we want to know which factor is contribute more than others, because we cannot look at every item for the factor, but we have to choose the impactful one. Okay, how to choose that? We use ANOVA ke MANOVA ke kat situ. Okay, and cluster analysis. And ini nanti kita tengok dekat kelas saya juga yang kat nanti dalam ANOVA. Okay, kat situ cluster analysis, it is group object, respondent, product, firm, variable, so that each object is similar to other object in cluster and different object in all cluster. This is the cluster analysis, is something about yang macam kita group kan, whether it has a similar punya apa sifat ke ataupun different sifat in other cluster. Okay, this is cluster analytic of eating out question. Okay, I eat at fast food restaurant at least once a week. Okay. Ini kita nak tahu kan, untuk yang makan kat luar. I prefer restaurant with highest quality food. And the third one, I prefer restaurant that have quick service. And the fourth one, I prefer to eat at restaurant that have a nice atmosphere. Okay, so now the objective is to identify group that maximize ratio of between group of variant with divide by within group of variant large divide by small. Okay, so we have 7 point agree and disagree scale here. Okay, so kat sini kita nak tahu to cluster whether this kind of group of people tu makan dekat luar seminggu sekali ke macam mana untuk eating out punya question. Okay. Kita nak tahu kumpulan-kumpulan mana kan. Kadang-kadang kita kalau macam contoh kita nak bina apa satu kedai dekat satu tempat, we have to know some kat keliling tu macam mana corak populasi kat situ kan. That's the cluster analysis. Then in this example of cluster analysis is construct a trust, commitment, cooperation, local self-control and job satisfaction and turnover for organization commitment, whether it is high, medium or low. Okay, and this is sambungan daripada cluster analysis just now. Whether kalau pola tu extreme, remove the middle group. Maksudnya dia ada satu group yang memang tinggi, satu group yang memang rendah, so we can remove the middle group. Okay, this is how we do the cluster analysis. And next is multidimensional scaling to identify unrecognized dimension that affect purchase behavior based on customer judgment of similarities or preference. Okay, and transform this into distance represented as perceptual map. Okay, this is what we call as multidimensional scaling. And for the correspondent analysis is use non-metric data and evaluate either linear or linear relationship in effort to develop perceptual map representing the association between object, for example, firm, product, and a set of descriptive characteristics of the object. Okay. And this is the guideline for this multivariate analysis. We have to establish practical significance as well as statistical significance, and we have to know sample size, effect or result, and we have to know about our data and strive for model parsimony and look at our error and validate our result. Okay, and this is a structured approach to multivariate model building. We have first stage, which is kita kena tahu what is research problem, objective and multivariate teknik yang kita akan guna. Yang kedua, develop the analysis plan. And the third one is evaluate the assumption underlying the multivariate technique. And the fourth one is estimate the multivariate model and assess overall model fit. And the fifth one, interpret the variance and validate the multivariate model. Okay. Okay, ini ialah primary database of variable. Okay, ini yang macam mana yang kita kata customer type tu metric ke, non-metric ke kat situ. And relationship measure dia kat sini, satisfaction, it is metric. Consider a strategic aligned partnership in the future is a non-metric. Inilah contoh-contoh and variable type dia. Okay. And here is multivariate analysis we learned today. What is the checkpoint? We have to know what is multivariate analysis, why we have to use this multivariate analysis. We want to know the relation kan kat situ. We want to know the most impactful. And the number 3 is what is knowledge of measurement scale important in using multivariate. Why is knowledge of measurement scale? Kenapa kita measurement scale tu penting? Sebab from the measurement scale we can determine what the technique that we are going to use. The number 4 is what basic issue need to be examined when using multivariate issues. Kita kena tahulah whether macam tadi tu kan macam kita isu je apa. Yang eating out punya tadi tu kan. Contohnya isunya kita nak tahu kenapa orang yang eating out tadi tu kan. So we have to know the issue. Okay, and for number 5, describe the process for applying multivariate analysis. Okay, and this is what I said just now. Example of multivariate analysis in market research company in Neural Center, and 11 multivariate technique, key tool in your marketing research survival kit. And also we have here the explanation which multivariate data analysis method to choose. And ni ialah masa COVID hari tu. Pfizer case study leveraging multivariate analysis for initial diagnostic and process understanding. Okay, this is all the example that you may read after this. And thank you. Selesai. Kelas kita hari ni dia tak ada mengira pun. Dia bercakap je. Okay, untuk yang ni. Next week. Okay, just now we already you learn on assessment for this course, right? So next week, midterm test. Is it okay? Midterm test. Okay, midterm test yang ni lah, test 20%. It's including the analysis of categorical data, non-metric statistic and multivariate data just now. Kalau macam saya punya part yang multivariate data analysis tadi yang kamu kena tahu ialah, contohnya I want you to describe what is an example for non-metric data. Macam tu lah, kita nak tahu kamu faham ke tak? Maksudnya give an explanation for type 1 error. Give an explanation and example of type 2 error, for example. You may use the example yang macam yang video tadi pun mudah juga, pun boleh juga. Asalkan kamu faham. Okay. But our class on Monday will be Deepavali, right?
Yeah, Deepavali one day.
Yep.
So how? But we are going to do a test. Tapi tak adalah kita buat hari Isnin tu. Maksudnya Deepavali, so semua orang cuti lah kan?
Yeah.
Jadi saya bercadang sebab kita akan jumpa on each lecturer, we have to meet face to face tau. Sekali at least. So, I nak propose ni, maksudnya saya nak kita punya face to face class on 18 November. Is it okay? Ada kelas lain tu masa tu, masa untuk metodologi ke, research methodology ke, ada ke masa tu? Kalau diam tanda setuju
Doktor,
Ha.
kalau ikut timetable untuk research methodology tu, waktu tu ada kelas.
Oh, dia kelas dia pukul berapa sampai pukul berapa?
8 pagi sampai 5 petang.
Okey. Yelah. Okey, sebab saya punya lagi satu 25 hari bulan, lepas tu hari Sabtu tu saya pula tak ada. Okey,
Split
tak
lah
apa.
doktor. Buat online dengan meet up tu.
Itulah. Ayu, ini memang kena kata setuju. Kalau student kata online, okey, saya memang okey online. Tapi kalau memang itulah. Kalau setuju online, kita buat on Sunday, okey ke? Sebab kawan kita ada yang kelas hari Saturday kan?
So doktor
Is it
test
okay?
on which day?
19 November.
Okay, Sunday night online test.
Do you want night or you want to make it on morning? I'm okay. Apa tu?
Prefer
Siapa yang
night
cakap tu
lah.
adik?
Tadi
night.
lain. I prefer night lah.
Oh, okay. Saya okay je. Kalau night, yang lain-lain okay ke?
12 night.
Yang lain-lain macam bujang je lagi kan, Eugene kan?
Yes.
Kalau pagi Ahad je pun betul.
Pagi Ahad okey. Tapi Eugene dia ada hal kot pagi Ahad. So kita buat night okey ke? Kita punya exam tu dalam 2 jam lah. Tapi kalau siap awal boleh hantar lah. Dia online. Nanti saya letak dekat Yulen. Nanti kamu kena submit dekat Yulen. Dia punya soalan, jawapan. Soalan pun daripada Yulen. But the previous, ya Nazri.
Yang malam tu saya travel ke outstation lah. So,
Bila? Ahad malam?
Ha.
Oh, okey, faham. Tapi actually yang lain-lain nak pagi ke malam? Kita ikut majoriti lah.
Saya mana-mana.
Mana-mana.
Pagi malam okey.
Okay, so sebab Nazri dia ada outstation malam, so pagilah ya. Tapi Eugene, is it okay
boleh.
pagi?
Boleh lah.
Boleh. Tapi
Thank you.
sebenarnya ikutkan siapa kalau ada sesiapa yang memang tak boleh malam ke pagi Ahad tu, but we can cater case by case because the question will be given on the time you are answering the question tu. Jadinya it can lambat sikit pun tak apa, tapi kena hantar. But yang sebelum ni masa Dr. Sek punya dia jadi penyelaras, dia minta buka kamera tau all the time masa jawab tu.
Okey, boleh.
Okey je kan?
Betul.
Tapi later on nanti saya bagi tahu pukul berapa, tapi semua orang setuju pagi. Tapi kalau ada sesiapa yang memang tak boleh, kita nak bawa ke malam ke, okey juga sebab soalan tu akan dibuka pada masa tu sahaja. Okey.
Okey, thank you doktor.
Okay. Thank you. See you next Sunday for the midterm test. But Sunday midterm test, Isnin jumpa saya lagi
Ya, 13. Yes.
13. Tak, 13 cuti Deepavali, Eugene.
Yes.
19 is the test.
Yeah.
But the 20 tu jumpa saya lagi untuk kita, okay, after we learn the multivariate data just now, we after this we learn how to clean, how to merge our data, how to, apa benda yang kita nak buat dekat data kita tapi guna R.
Okay.
Okay.
19
Dia
test.
macam lab session lah. Ya?
19 ada test dan 20 ada kelas lagi. Yes.
Betul.
Okay.
Okay. Thank you everyone.
Thank you.
Bye.
Sorry.
Ha?
Maksudnya yang hari ni punya kita belajar, ini je yang cover untuk test kita lah.
Ya, betul. Betul sangat.
Oh, maksudnya
Tak susah pun.
maybe sample question just nak tahu how to differentiate metric dan metric.
Maksudnya data tu ada berapa type? Can you give an example for that kind of data? Kalau type of error tu apa? Can you give an example of type 1 error, type 2 error? And what is the factor to give a more power punya result? What is the factor just now? Sample size kena besar. Jangan letak skala alpha tu kecil sangat. Betul tak? The effect of the power. Yang itulah yang saya punya macam lebih kurang kita jawab soalan sejarah lah. Saya nak cakap.
Ada ke, sorry doktor, ada ke sample question ke saya boleh access dekat library?
Sampel saya tak ada sampel tu. Tapi kalau sampel tu saya rasa maybe kalau kamu nak sampel ke apa, cuba tanya Dr. Sek. Soalan dia ada sampel tak? Kalau macam saya punya soalan macam tu lah. Sama ada saya nak tanya. Sama ada saya nak tanya data macam mana. Tapi Dr. Sek mesti ada bagi contoh-contoh.
Dah bagi contoh dah.
Okey. Kalau yang saya yang macam tu lah, macam kita tahu type of, kalau macam contohnya saya kata saya punya masalah tu guna non-metric, but we in the dependence punya maksudnya situation. So kita sepatutnya kita yang apa yang possible teknik yang kita guna, yang macam table tadi yang banyak-banyak turun ke bawah tu kan. Mungkin boleh tengok yang tu. Okey. Macam tu je. Tak susah. Okey. Terima kasih. Jumpa minggu depan. Good night. Bye.
Good night.
Thank you.
Thank you.
Thank you, Doktor.
Thank you.